Welcome to video lesson 9.6, factoring difference of squares. Go ahead and put today's date in the top right hand corner. And our target for today is that I can factor polynomials by difference of squares. Now, difference of squares factoring is for two terms, like how GCF is for any number, grouping is for 4, DOS is for two terms. A lot of times when I'm talking about difference of squares, because it's a long name, I'll just call it DOS. That way, it's a little bit shorter to say, and also whenever we write out what type of factoring we need to do, DOS is easier to write than difference of squares. So the word difference in math we know means to subtract, and we know what squares are. So that comes into play with our two terms. Our two terms must be subtracted or their signs must be different. So that's the difference part. And then squares. Squares means variables must be to an even power or squared. And our coefficients, let me scoot that down a little bit. Coefficients and constants must be perfect squares. Now, we're going to make a perfect square list for those of us who aren't sure what perfect squares mean. That way we can see them. So, our perfect squares. Basically, it's just that number squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. This is a good list to make out, that way you can know that all of these on the right side of the equal sign are your perfect squares. Then the left side tells you what numbers makes them. So it's like if I were to ask you, what is the square root of 49, you would know it's just 7. And also, if you think about something being squared, we've talked about this before. If I have x squared, it breaks apart into x and x, so that means I have two x's. The same way, if I have 7 squared, that means I have 7 times 7, and 7 times 7 is 49. So that means we have two of the same number being multiplied. Alright, one thing just to remember is if you don't remember your perfect square list, the opposite of a square is a square root. So if you want to know the perfect squares of 64, then just take the square root of 64 and you'll get 8. So if you take the square root of like 50 and it gives you a decimal, you know it's not a perfect square. The perfect squares give you a nice whole number. Alright, our steps. Step 1 is always to check all terms for GCF. That's always the very first thing we do. Then step 2, we're going to check and make sure our polynomial only has two terms, because DOS is only for two terms. Make sure it's subtraction, and make sure our terms are all perfect squares. Find square roots of all the terms. And lastly, our answer is written, and we have two parentheses again, two binomials like we did with grouping. So our first parenthesis has the first square root, and this plus sign, our second square root. And then our second parenthesis has our first square root minus our second. So basically, the parentheses are going to have the same things in them, except for one's going to be a plus and the other parenthesis is going to be a minus. So let's see an example of a DOS factoring. So example 1, we have x minus 16. So x squared minus 16. So very first thing we do is check it for GCF. His coefficient's technically 1, so I don't have to show a GCF of 1. He has an x, he doesn't, so no GCF. So then we know it's a DOS. Because I have two terms, x is being squared, and 16 is on our perfect square list, and they're being subtracted. So Two terms, subtraction, perfect squares, we're good. So then we take the square root of both of these terms. So the square root of x squared, and the square root of 16. And what I like to do at this point is just go ahead and make my two parentheses. And say square root of x squared cancels and just leaves me with x. So goes in first and the second parenthesis. And our signs are different, so a plus and a minus. And then square root of 16 is 4 and 4. Now you can check these the same way we check our other problems. It's the opposite of a FOIL problem. So if you look, this is a special product because I have one that's a plus 4 and the other one is a minus 4. So special products means we just have to multiply our first term. So x times x gives us x squared. And our last, 4 times negative 4 is negative 16. And we check x squared minus 16 is our original problem. Let's see another one. We have 64 y squared minus 81. So the very first thing we do is check it for GCF. So 64 cannot go into 81 evenly. You try the factors of 64, they still don't work. He has a y, he doesn't. So there's no GCF, so then we move on to DOS because we have two terms and we check it. 64 perfect square. Yep, it's on our list. Y is being squared, and 81 is also on our perfect square list. And lastly, we are subtraction, so we're good. So we're going to now move on. We're going to take the square root of everything here. So square root of our first term, square root of our second. We're going to make our two parentheses. There we go. So square root of 64 is 8, so I put 8 first in each. Square root of y squared is just y, so 8y and 8y. Our signs are different, so it's going to be a plus and a minus. Square root of 81 is 9, so 9 and 9. That's our answer. There we go. So let's move on to a couple of other examples. Our next one has 9x squared minus 25y to the fourth. So once again, the first thing we check for is GCF. 9 cannot go into 25 evenly. Factors of 9 cannot go into 25. He has an x, he has an y, so there's no GCF. So then we say 9 is a perfect square, x is being squared. We have subtraction. 25 is a perfect square, and y is to an even power, so that means it's a DOS. And now we take the square root of everything here. I make my two parentheses. Now, square root of 9 is 3. So 3 and 3. Square root of x squared is x. Alright, my signs are different, so a plus and a minus. Square root of 25 is 5 and 5. Now, y to the fourth, it has to be to an even power because, like how we said, x squared breaks apart into x and x. Well, our y to the fourth is going to do the same thing. Y to the fourth is going to break apart into y squared and y squared. So it has to be an even power so I can separate it evenly. If it had been to the 6th power, it would have been a 3 and a 3. So the square root of y to the fourth is y squared and y squared, because it can break apart evenly into 2 and 2. There we go. And also, if you think about when we're multiplying, you're going to add your power. So y squared times y squared is going to be y to the fourth because you add them 2 plus 2. All right, example 4. We have 8v to the third minus 18v. Step 1, we check for GCF. And both these numbers are even, so we know it has a GCF of at least 2 because they're both even numbers. So we see, can 8 go into 18 evenly? No, so then we find our factors of 8. We try next 2 and 4. 4 is bigger, so can 4 go into 18 evenly? No, it can't, so then we use our 2. and 2 can go into 18 evenly, so GCF of 2, and they both have v's. I want the v with the lowest power, so that's just v. So I divide everybody here by 2v. And because it's GCF goes on the outside, I'm going to make my parentheses. So 2v, then 8 divided by 2 is 4. V to the third divided by v gives me v squared, minus 18 divided by 2 is 9, and v divided by v cancels. Now this is just using our rules for monomials, knowing that if that's 3 and that's a 1, we subtract. So 3 minus 1 gives us v squared, and v divided by v cancels. So we have to use those monomial rules still when we do our GCF. So now we check inside this parenthesis. And we look, it has 2 terms, 4v squared, so both those are perfect squared. It's subtraction, and 9 is a perfect square. So that makes it a DOS now inside there. So that means we're going to have to break apart our 4v squared minus 9. So I'm going to drop down my 2v, cannot lose my GCF. We know this breaks apart into 2 parentheses. Now we find the square root of 4v squared. So square root of 4 is 2. Square root of v squared is just v, so 2v, 2v. Signs are different, a plus and a minus. And then our square root of 9 is 3 and 3. That's our answer. Okay. Last set of examples. We have 25 y squared plus 16. So we check first for GCF. We say, can 16 go into 25 evenly? No, it can't. So then we say factors of 16 are 4 and 8 and 2. None of those can go into 25. He has a W, he doesn't, so there's no GCF. He's a perfect square. W's being squared. 16 is a perfect squared. The problem is I have a plus sign instead of a minus. So this one is what we call prime. It cannot be factored because a DOS problem has to be subtraction or be different terms. Or, sorry, be different signs. And those numbers are both positive. Both those terms are positive. So it has to be a subtract, or you have to have different signs. One has to be a positive, one has to be a negative. So our last example then has negative 100y squared plus 49. Once again, you check first for GCF. 49 can't go into 100 evenly. We don't have any factors of 49 that can go into 100. 100 is a perfect square. Y is just being squared. 49 is a perfect square. So we're kind of thinking it's a DOS, but once again, it has a plus sign. What makes 6 different from 5, though, is that 100 is a negative. So that means where he is a minus and he's a plus, I could change the order of these two and rewrite them and say a positive 49 and a negative 100 y squared. Does that look like a DOS problem now, where we have perfect squares and subtraction? Yes, it does. So now I can find the DOS of it. So, square root of 49, square root of 100 y squared, and we get our 2 parentheses. Square root of 49 is 7 and 7. Okay, and then we have, our signs are different, a plus and a minus. Square root of 100 is 10, so I put a 10 in each, and square root of y squared is y, so y in each. And that's our answer. And that finishes up for our DOS. Thank you.